Why pi? This is an activity using the TI-83, 84, and 84 CE. Hi, this is Tom Reardon, math teacher from Ohio. All the materials and much, much more are available at this bit.ly website down here. It is case sensitive. Press pause to copy that down. So why do we have a number like pi? Let's investigate. We're going to run the program called ypi, and in list 1 will be the lengths of diameters, different sized circles, and L2 will be the circumferences of those same circles. And we'll get that. So let me go ahead and do that right now. So go to program. This was already preloaded, and you'll be able to get that and load it onto your calculator, emulator, or your students. So I'm running the program ypi. It places the circumference and diameter data into list. Press enter, and it did it. This will work on the 83, 84, and 84 CE. So I'm going to go ahead and press Stat and Edit, and there are those numbers. Again, it's the diameter in L1, circumference in L2. So again, where does the pi come from? In the student activity that's applied and the teacher notes and solutions, it asks the students to solve for pi in the circumference equals pi times diameter. Okay, we divide each side by the diameter, and we're left with C divided by D equals pi. We're going to show that in the lists, L1 and L2. So in list 3, we're going to type in list 2 divided by L1. So moving my cursor to the very top of the list where it says L3 equals, I'm going to go ahead and divide second 2, which is L2, divided by second 1, which is list 1. When I press enter, it will divide that for all of those values. In the activity, we're asked to use the arrow keys to look at each of the values in the cells for L3. Even though it shows 3.1416 displayed, you can see many more significant digits here. And you can see that pretty much the numbers are about the same number, maybe not to the last final decimal point, but it's pretty much the same. And you're asked to compare the answers we're getting with pi to 20 decimal places, and pause to do so. Another part of the activity asks us to look at that data in list 1 and 2 and to plot it in a stat plot. So I'm going to go ahead and press a second y equals and press enter for plot 1. I want to turn it on. The type is to be a scatter plot. X list L1, that would be second 1 in case it's not there. Second 2 will be list 2. The big mark's fine and the color blue is fine. But we also have to make sure we have an appropriate window for that data. Okay, so that would be a good thing for the students to discuss. Fortunately for us, I came up with that, but in your classroom, that would be what they would have to talk about. So for the window, I'm going to have it -1 for the X min, 12 for the X max, and show every 1. And -5 so that I have a place to trace up to 40 in steps of 5. Press pause if you're doing this along with me. And press graph. And it looks like the data is linear, and so ask the students by trial and success or guess and check to come up with an equation for that. Many of them will try maybe simply like 3 times x, and we'll go ahead and graph that, and it looks decent, but hopefully they realize the exact answer would be second caret pi times h, and that would be perfect. Again, that would be pi times x, or for pi times d. So to obtain all files and learn about Einstein's birthday and facts about him and quotes from him, we suggest you go to this bit.ly, March Madness. And this is my actual pie pan that I have in my office.